Hey guys, I'm back. Cody Powers, Chem 1005, Unit 2 case connections. So just did case 1 about pyruvate kinase regulation. Now I'm going to do case 4. Basically, a mom presents with her 2-month-old female who's been having jittery spells several hours after breastfeeding. The baby's only ever had breast milk since birth. Um, Lab results show hypoglycemia, otherwise unremarkable. Epi is given, and there is no increase in blood glucose, but there is an increase in blood lactate. She has an enlarged liver. Um, Basically, she can't maintain blood glucose levels within a normal range during fasting. So, based on this information, what is the most likely diagnosis of this patient? Is it hereditary fructose intolerance, galactosemia, glycogen storage disease, or glucose 6 phosphate dehydrogenase deficiency? And basically, they want us to kind of go over each of those diseases and then kind of like a detective work, basically. Why is this baby having hypoglycemia during fasting? So, um, basically, I'm just going to talk about hereditary fructose intolerance first. So, of note, breast milk is lactose, which is basically galactose and glucose. So the baby isn't even ingesting fructose, so it's not anything to do with hereditary fructose intolerance. It's a different pathway. But hereditary fructose intolerance, there's a deficiency in aldolase B, and fructose 1 phosphate accumulates. And the consequence of that, fructose 1 phosphate elevation, is that all the free phosphate is used up. This causes a decrease in gluconeogenesis in the liver. And if we're not able to do gluconeogenesis, we're going to have hypoglycemia and impaired ATP generation. So people with hereditary fructose intolerance, they're often have hypoglycemia and they're lethargic. So our baby does not have this. The baby is not ingesting fructose. So galactosemia, basically the cell can't metabolize galactose. Like I said, the baby's only ingesting breast milk. Breast milk is lactose, and lactose is made up of galactose and glucose. So the baby, if it was galactosemic, wouldn't be able to use the galactose, but it would be able to use the glucose in the breast milk. So the baby would basically have normal fasting glucose levels if it did have galactosemia, because basically if you just avoid the ingestion of galactose, you will treat galactosemia. And in my paper, I go into how lactose is ingested in the intestines, and then it's hydrolyzed in the intestines, and then glucose is actually used as a fuel source. So galactosemia would not cause the symptoms that are shown in this baby. I'm going to skip to glucose 6 phosphate dehydrogenase deficiency. This actually affects the pentose phosphate pathway, which is kind of an offshoot of glycolysis. The phosphate pathway produces NADHP, and then it also produces ribose 5 phosphate, which ribose 5 phosphate is it's necessary for nucleotide and nucleic acid formation, and then NADPH, it maintains reduced glutathione, and glutathione is basically an antioxidant. It protects the red blood cell from H2O2, which will actually destroy cells. It'll lyse cells. So people with glucose 6 phosphate dehydrogenase deficiency have anemia. This is also part of the pentose phosphate pathway, which is distinct from glycolysis. So our fasting glucose levels should be unaffected. Because of this, we can eliminate the other 3 options. It appears the baby has a glycogen storage disease. which is the inability to use glycogen. Basically, when she ingests the milk, the galactose, she can use the glucose to keep her blood glucose within normal levels. But when she's fasting and needs to use glycogen, she is unable to. And the enlarged liver is presumably occurring from glucagon accumulation, trying to raise citric AMP levels, trying to break down glycogen. Glycogen storage diseases are characterized by the impairment of the liver's ability to break down glycogen, and it's caused by a deficiency of glucose 6-phosphatase or glucose 6-phosphate translocase. And these are the steps in gluconeogenesis, a couple of the enzymes, gluconeogenesis and glycogenolysis. So, like we've already kind of discussed, in the fasting state, epinephrine, glucagon are released, stimulating citric AMP. Citric AMP then actually like stimulates or helps glycogen phosphorylase break down glycogen. Glycogen becomes glucose 6 or glucose 1-phosphate. Glucose 1-phosphate is then converted to glucose 6-phosphate. And you know, since the muscle was able to use glucose 6-phosphate for energy, but the liver wasn't able to use it to create free glucose, it can be determined the baby is lacking the enzyme glucose 6-phosphatase. And that's really it. So yes, this is a glycogen storage disease, and it is called von Gehrig's disease. Thank you.